So let's all to calculate the value of x given the pattern -1, x 3, and we've got x plus 8. Now let's not forget that this is a quadratic sequence, so we will basically use arithmetic rules to tackle this one. Arithmetic pattern rules. So in other words, we will be using the common difference form: t2 minus t1, t3 minus t2 equals t4 minus t3. We will stop at this because we have a total of 4 terms. So now let's go ahead and substitute them and see what we get. That'll be x minus 1, 3 minus x plus 8 minus 3. You got x plus 1 equals 3 minus x. And you got 3 minus x equals x plus 5. If I bring x on this side, I'll have x and x, take the 1 on the other side. I'll have 2x equal 2. And if I do the same here, 3 minus 5 equals x plus x. I'll have minus 2 equals 2x. Now we see how that these two are actually equal. So 2x plus 2x, if I group the like terms, I'll have 2 plus minus 2, which is of course 4x equals 2 minus 2. 4x will be 4. That will be 0. That means x is actually 0. Second question says, if x equals 0, determine the position of the first term in the quadratic number pattern for which the sum of the first n first differences will be greater than 25. So we will need two things. We will need the original sequence, original quadratic sequence, and of course we will need the first difference of the quadratic sequence, and of course the second difference will kind of help us work out the first difference. So basically this part would definitely resemble the arithmetic pattern. So in other words, we still stick to the rules that are used when working with arithmetic patterns. So if x is 0, we are to find the sum of the first n. So we are calculating n for which the first difference will be greater than 250. In the space of x, I put 0. Oops. That's 8. Let me just write it out properly. 0, 3, and 8. So I'm going to keep using the arithmetic pattern rules as I've said before. So t2 minus t1, that's 0 minus 1, that's going to be plus 1. 3 minus 0 will definitely be what? Pardon, 3, then 8 minus 3 is 5. And this is my first difference. Which I said to you will resemble an arithmetic pattern. So this is my Tn. Basically. And of course, if I subtract 1 from 3, I get 2. If I subtract 3 from 5, I get 2. And this is my second difference, which is actually my common difference. So using the sum knowledge, sum of the first n arithmetic terms will be n over 2 into 2 times the first term plus n minus 1 into the common difference. So I'm going to go ahead and substitute all these guys into this formula. Of course, the first term of my first difference is 1. N is what I'm looking for. The common difference is my second difference, which is 2. That'll be 2 plus 2n minus 2. N over 2 into 2n, because these two will cancel out, leaving us with Sn equals n squared. Now, this is where we actually get to answer the question, because we are looking for the n for which this guy is said to be greater than 250. So go ahead and substitute that and find n. That's of course n squared minus 250 will be greater than 0. Difference of two squares. So basically n will be greater than plus minus 250, but of course we are gonna actually look for the positive one, because the negative one is, cannot represent position. So if we round it off, that will be approximately 15.8, which can be rounded off to the nearest digit to be 16. So in other words, it is at the 16th term of the first difference that the sum of the first differences will be greater than 250. However, we are looking for the position of the first term in the quadratic number pattern. So if Tn for the first difference is represented by T16, the solution we are looking for when you get to the quadratic pattern will be the 17th term. So the answer to this is T17, or you could just say n equals 17. So all the information given there already tells me that we are working with a geometric sequence, or we could just say pattern. So the basic rules for the geometric pattern is that the terms are described by the formula Tn equals ar to the power n minus 1, where a represents the first term and r represents the common ratio. Now from the statement we have both of these two, because already the first rectangle is said to be 21 centimeters, and we are told that the length of each successive rectangle is 85%. That's the common ratio, meaning if my first triangle is 21%, right, 85% of 21 would of course be 17.85. So that means there is a common ratio. These terms are separated by a common ratio, right? So R would be 85%, but how do we express percentages in, let's just say mathematically? Well, there's two ways. We could use the fraction route or just decimal points, and I prefer the decimal points. So that will be 0.85. So when we get to the first question, we were asked to actually calculate the length of the 10th rectangle. So using this information provided, we can simply say Tn equals 21 0.85 power n minus 1. So the 10th rectangle would mean that n is 10. That will be power 10 minus 1. That will be power 9. So if you use your calculator, you will get an exact answer of 4.863955.872 centimeters. But if you round this off, say to what, 2 decimal places, that will be 4.86 centimeters. So in other words, the 10th rectangle will be 4.86 centimeter. Next question says that we should calculate the percentage of the paper that is colored gray. Well, firstly, we know that the whole page is actually 30 centimeters. That's number one. Number two, we know that there's a gap between the pages, which was said to be 1 centimeter. So that means every triangle is 1 centimeter. Did I just say triangle? Pardon. Every rectangle, I meant to say, is 1 centimeter apart from the other. So for us to fill a whole page with 1 centimeter gaps would mean with 1 centimeter rectangles as well, or rather rectangles that are 1 centimeter long, that would simply mean that the page will have half of its part covered in gray or colored in gray. So that means that the gray part of the page would actually be 50% of the page. And that will be, of course, 15 centimeter. So this formula is more like, or rather this question is more like us trying to find the sum, right? The sum of the lengths put together, lengths of the triangles. So of course, the formula for sum in geometric sequences will be Sn equals A into R power n minus 1 all over R minus 1. Of course, previously we saw how that A would actually be 21 and common ratio can be described as 0.85. So this becomes pretty easy because all you do now is substitute. So the 15 here becomes our n, because that's the number of rectangles that we have. So that's going to be S15 equals 21 into 0.85 power 15 minus 1 all over 0.85 minus 1. Now you could go ahead and use your calculator. That's 127.77. So from this we can actually then go ahead and find the answer, because we're looking for the percentage of the paper. So the whole paper is actually a rectangle. So the area of a rectangle is length by breadth. We are told that the paper is 30 centimeters long, and the first triangle fills up the bottom of the page with a length of 21 centimeters. So the area of the page is actually going to be 30 multiplied by 21. That's for us to find the area of the entire page, 630. So that's like the total of the page. So how much of this is actually covered in gray? covered in gray, divided by area of page. If I, for lack of a better way of putting it, so that's going to be 127.77 divided by 630, and that's approximately 20.28%. So in other words, 20.28% of the page is actually covered in gray.